Now, let me tell you one thing. The moment once your file is split,
Yeah.
the moment once your file is split, okay, and that particular file has to be written across multiple blocks, block writing, that is the split writing across multiple nodes is done in parallel.
So that is where my doubt is because I've been reading so many manuals, and that is
Yeah.
where the confusion is. Can you please point out a document wherein it says that HDFS file writing happens in parallel? Because what I'm reading across the manuals and all that, does not happen in parallel.
No, no, no. Have you seen this HDFS definitive guide, orally publications?
Oh, HDFS definitive guide. Yes, yes, I've seen that. So there it is
Yeah.
explained, this one.
Yeah, I'm not sure which source it has been mentioned, but one thing
Okay.
what happens is that uh, s- the moment once this file is split up,
Yeah.
okay, and then once we are aware of these particular blocks, you think logically, okay. Uh, Let me take it with the help of a diagram if possible, then we can see. One minute, hold on, please. Hi, Divya. Okay. I think Kamran and Murli, you guys have understood the question what Saravanan is asking. 1 minute. So here you have a file here. Okay.
Mm-hmm.
Assume that you have a file of
I'm not
which
able
is
to
of
see the screen. Uh,
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 1 minute.
yeah, sure.
Let me share the screen first. Okay. So this is what is your terabyte file here. Okay.
Yeah,
Now this is what is your name node. Okay, this particular name node will have the multiple data nodes that exist. It will be of, I need to tell you one more thing called as the rack awareness concepts also I need to tell you, but of course, this is not required at this point of time. That's why I didn't talk about that particular rack awareness concepts, but still, okay, you have these three or four data nodes that are existing here. Okay, now assume that this 3 terabytes of file, uh, assuming that for the sake of the example, we are assuming that that is split up into 4 blocks or 3 blocks.
yeah,
Okay, now is split it into 3 blocks like this. Okay, now the thing what you need to understand is that each and every block is expected to go onto a different node. This will go here, as
right,
well as this is expected to go into this particular block, as well as this is expected to go into this particular block. Okay,
right.
now do you think that is there will be any showstopper for writing this particular 3 blocks in parallel in these 3 data nodes? It won't be the case, right?
Correct, correct. Okay, it is correct. But I went through that exactly the same question, Ravi. But if you, the flow chart we discussed was that the HDFS client first writes the first block into its local, caches it into its local file system. And then when it writes the first block, it is only then it goes to the name node and asks, hey,
No,
no,
no, no, no. It's not like that. What
okay,
happens is when the name node tells the client, okay, or else the moment once the file comes under the control of this name node, what happens is that file splitting happens, right? Assuming that this file splitting has happened and you have been assigned the task of writing this particular blocks. writing these particular blocks to this particular name nodes, what happens is that first node is written here. Okay, now this will be having a default replication of 3, right? This will be
Yeah.
having a default replication of 3. Then this name node, this data node takes care of replicating this particular block onto the subsequent data node. That is something which is going to happen in sequential. Okay, but the blocks that are being written to the data nodes will happen only in parallel, server.
Okay. Okay.
See, why? Because this name node is this data node is responsible for the purpose of writing the second replica, and this data node is responsible for the purpose of writing the next replica. Okay, and the first data node where the first block has been inserted is responsible to make sure that the replication is happening on the second data node. So that's why in such a case, name node will not have any control on that one. Okay,
Okay.
name node will have only control when it is writing the first block onto its first data node. Okay, so that's why these blocks, when they're being written in the first time, these things will happen in parallel. These things will happen in parallel, but the subsequent blocks, what you are having here, is something which will be written in what we can say, which will be written sequentially. Okay.
That's what I said. So the first block, so in a block, the replicas will be written in parallel. I agree with that.
Replicas will be written in sequential. Replicas will be written in sequential.
No,
blocks will be written in parallel.
No, what I'm reading is that the blocks will be divided into smaller chunks, 4K or 8K chunks, and it will first write to the first data node, and that data node will immediately write it to the next data node, and that will write to the third one. And so
No.
data node may be receiving data and sending data at the same time.
No. That is not the case. That is not the case.
Okay.
Because
can you provide the reference where you read it?
Yes, I can send.
If you can provide the reference, so we can also read it.
Definitely,
we can have an
do we have a
understanding.
group email ID? Do we have a group email ID?
We'll create one group email ID basically. We'll create.
Okay.
And then we'll take it forward. Okay.
Sure.
So no issues on that one. Okay. But as per my understanding, this is what happens. And logically also what I'm saying is right, Sarvanan. Okay. These blocks are independent. When the blocks are independent, it is always logical to write these blocks in parallel to these data nodes. Okay. But the corresponding replicas is something that has to happen in sequential. Why? Because the data node is responsible for the purpose of writing the replicas, but not your name node. That is the reason, as per that particular theory, which you have read from, if you can see here, I have so many books that are readily available for ready reference.
Okay. So that only I want. You can show.
I just want to give the input of this thing. If logically, like if it is sequentially block writing, it obviously process is going to be slow.
Yeah.
So replica always be inside the architect. Yeah.
Yeah. See, I have this Hadoop 2, I have this Hadoop solutions, I have this Hadoop explained big data made easy, and all these things. So that's why, yeah, that's why it runs basically. Okay. Now coming back, where we have left. Yesterday we have seen a couple of Linux commands that will make you to work on this particular Linux operating system. But Linux is very much easy. I have told you, right? You are expected to have a virtual machine. For playing that virtual machine, you need to have the VM player, virtual machine player. Okay, and you have to have a host operating system for the purpose of launching that particular VM player along with your virtual machine. Why? Because the virtual machine in turn will be taking your host system resources for the purpose of its running and other things. Okay, so this is what is your Windows operating system, as I was showing you. And Windows operating system, I have two versions of virtual machines. One is one is Oracle related VM player, and the second one is the normal VM player, VM workstation that we are having here. So I have told you I need to power on this one, making sure that CentOS is nothing but the Linux flavor of your operating system. So this is running here, and on this one, I have this Linux that is installed here. Linux that is installed here. Okay, so it comes. So, Saravanan, yesterday I was telling you the difference between the local file system and the virtual file system, right?
Yes,
The first difference, what I have told you is local file system will have its own associated operating system, whereas virtual file system doesn't have any associated operating system. Okay,
correct. It's a layer of
and
abstraction used to
yeah,
please.
and virtual file system always depend on the local file system operation for its operation here. So one thing what I have told you yesterday is when you have this particular slide, okay, if this is going to be your operating system, which is in the form of Linux file system, okay, and using this particular Linux file system, you are going to have this HDFS that is being installed. HDFS that is being installed, which is in gray color like this. Okay. Now I need to start interacting with Linux, as well as I need to start interacting with HDFS also as well. Okay, so for the purpose of interacting with Linux, I have told you a lot of Linux commands, and also I have told you there is a 80-20 rule. What is that 80-20 rule? 80% of your programming or your Linux operations can be done by knowing only 20% of the commands. Okay, so among those 20%, I have told you how to create the directories, how to move the files, how to delete the files, how to create the directories, and then how to what you can say, display the contents of the files, what is your root directory, that hierarchical structure I have told you. Okay, and also I have told you something called as a home directory. And within that particular home directory, there is a difference between with respect to Linux as well as with respect to Windows also as well. Okay, within Windows, how do you know that you need to approach to that home directory? The moment once you go to this place, and then when you start giving this cmd command, you'll be able to see this c:users slash Ravikumar is nothing but the home directory. Why this is treated as the home directory? Why the reason is whenever you start logging into that particular shell, you will be defaultly be placed in that particular directory. That's why that is treated as the home directory. Okay, so in Windows, what you have here, you will have the directory C directory, D directory, and E directory, and each and every directory will have its the corresponding home directory that exists. Okay, now, but that is different in the case of Linux. The reason why it is different in the case of Linux is I have told you. When you enter into this particular computer, you will not be able to see any directories, right? C directory, D directory are like that, you will not be able to see, but you will be able to see only this particular file system. The moment once you open this particular file system, this slash / what you are seeing here is generally treated as the root directory, and under that particular root directory only, there will be a lot number of directories that exist here. Okay, there will be a lot number of directories that exist here, and when you click on this particular home, you'll be able to see this particular Edureka, which is treated as the home directory. So any work that you do, or the moment once you start opening your terminal, you'll be able to be placed in this particular directory. What is the directory here? You'll be able to see here. This is root / home / Edureka. This is the place where you'll be placed the moment once you start working in this particular shell or the interpreter. So this is the story with respect to the local file system. Okay, but when you talk about this particular virtual file system, we need to really understand how can we interact with this virtual file system. Okay, so for the purpose of interacting with this virtual file system, there are two ways in which you can interact with. Okay, The first way of interacting with respect to the virtual file system is, first one is you can have the option of trying to interact with the help of the browser. The help of the browser, and what is the second one? You can have the option of interacting with the help of the terminal also. You need to interact. Browser. Okay, the moment once you start interacting with the browser, what happens is that you will only be able to view the contents, but you will not be able to manipulate the contents basically. You will not be able to manipulate the contents. So for the purpose of manipulating those particular contents, you need to depend on a host terminal. That particular terminal is nothing but the Linux terminal. That particular terminal is nothing but the Linux terminal for the purpose of working. Okay, these are the two things that you need to really understand for the purpose of working with the virtual file system. Okay, so is it clear, guys? Sarvanan, Murli, Kamran, and Divya.
Yeah, it's clear.
Any questions?
So there is no
Yeah.
possibility to write anything via browser?
There is no possibility to write anything in the browser. Even when you try to open your Mozilla Fire, I'll show you all these things. When you start opening Mozilla Firefox or Internet Explorer, do you think that you'll be able to write anything interacting with the directories? You'll not be able to do that one, right? Basically. So that is the same that is going to happen here. But I'll show you. And another thing, what I'm going to show you is maybe tomorrow during the weekend I'll be downloading you with material that is required. But one thing that I'm saying is if your computer doesn't have this minimum 6 GB RAM or 8 GB RAM, and if you don't have this particular 500 GB hard disk, which is the minimum configuration, I suggest you to work on this particular putty.exe. You need to oh my god, you need to download this particular putty.exe, and then you can connect to a particular virtual machine which is existing on the cloud. That cloud might be an Amazon cloud, it might be an Azure cloud, or else it might be any other cloud, so that you can directly connect to this one. So multiple ways for the purpose of working with the virtual machines is putty.exe you can use, or else you can have the option of using this Oracle VM VirtualBox, or else with the help of this virtual machine 12 player. These are the three ways in which you can have the option of interacting with. Okay, now when you come on to this when you come on to this screen into this Linux virtual machine, let me show you. Here I'll go to this particular browser, which is nothing but the Firefox web browser. I'll go here. What are the components of the HDFS file system? What are the two major components that we have really talked about? Can anybody tell me? What are the two major components of your HDFS file system?
Name node and data node.
Great, thank you. There you go, name node and data node. Your client will be able to access only the name node, okay, but how many data nodes are there and how to access those data nodes is something that we need to really look into at a later point of time. Okay, when you go here and when you come here, I'll tell you, I told you, right? Name node is a virtual file system. Name node is a virtual file system. If you want to really look into what are the contents of this particular name node, what you do is that you go to this place, that is http:// localhost colon 50070. 50070 is nothing but the place, okay, where your name node exists. The moment once you click on this one, you will be able to Sorry, I will go here. Localhost 50070. So you are seeing here, right? This is started on March 11th, compiled, and here you can see here. A client will have this particular safe node, right? Safe mode is there, right? Sarvan, I was telling you, right? What is the safe node? What are all the things I was talking about, right? So
Right.
this is the safe mode that you are having here. I also told you something called as a checkpoint.
Right.
Okay. I also told you something called as the edit logs.
Correct.
Okay. I also told you something called as the FS image.
Right.
These are the things that you are having here. Okay. And also I have told you something like how many live nodes are there? There is only one live node. What are the live nodes here? The live nodes are nothing but your data nodes. Divya, you are following. The live nodes are nothing but the data nodes. Okay.
Right.
So since it is nothing but a single machine installation, you will have only one name node and then you will have only the one data node, and both that name node and data node will exist only on the single machine itself. Okay. So by seeing this particular name node, you will be able to understand how many dead nodes are there. Okay. Now you can go to, you will be able to see all those particular dead nodes over there. You'll be able to see all those particular dead nodes over there, and using those particular dead nodes, you can go ahead and then start spinning them once again, or else trying to make some changes. All those things can be seen with the help of this particular logs basically here. Now I'm really interested in this particular file system, right? What is this file system here? The file system is nothing but your virtual file system. Virtual file system can be accessed only in two ways. One is with the help of the browser, and second thing is the help of the terminal. Okay, so if you want to see what is this particular file system, please open this one. Browse the file system. What is this directory here? This is what is your root directory. Guys, please understand, this root directory is different from the root directory what you are seeing in the Linux file operating system. Sarvan, this is clear, right? This root and that root is different.
Okay.
This root what you are talking about is nothing but your HDFS root directory.
Okay.
Okay. Now you need to go to this particular user, and within this user you will have this particular edureka. /user/edureka is nothing but the home directory of your name node of your HDFS file system.
Okay.
Clear what I'm talking about? And what is the default block size? What has been given? The default block size is only 128 MB.
Okay.
Okay. And what is the size that you are having here? The size is something like 382. This is the thing that you are having here. And what is the replication factor? The replication factor is only 1. Why do you have this replication factor only 1?
Because we have
the reason, yeah, why? Because since this is only a single node installation, you are having this replication factor that is specified as only 1 in this particular case. Okay. Now, another thing that I want to let you know is in case of normal file system, the NFS, networking file system, or else if you take any other file system, what is the default block size that will be allocated whenever a file is created? Any idea? What is the default block size that is allocated whenever a file is created? It will be of 4K, right? What is that 4K? That is nothing but your 4096 bytes that is created. Okay, 4096 bytes it is created. That means that every file, when it is being created, it will be split into 4 KB, which is nothing but your 4096 blocks. This is the default for your Windows file system, or whatever it is. Okay. Now, among those 4096 blocks bytes, if you are able to utilize only those 3000 bytes, can you tell me what happens with respect to the other 1096 bytes, Sarvanan? Divya? My question is clear to you. I'm utilizing only the portion of the block space, but what happens to the remaining portion? Will it be set as it is, or else it will be used by other programs? Hello?
Sorry, can you repeat the question actually, Ravi, once more?
Yeah, you have a file which is of block size 4K,
Okay.
okay, which has been allocated. Out of that one, I am using only 3000 bytes.
Okay.
Now, what happens to the other 1096 bytes?
Yeah, it will be used for updates and other processes, right?
No, 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 no.
No?
S- What I'm saying is that whole and soul, the file itself is of 3000 bytes only. 3000 bytes only. In such a case, what happens?
So still 4K will be allocated because that is the OS block size.
Yeah, that means that the unutilized space will be wasted, right? The
Right.
unutilized space will be wasted
Correct.
in the case of the local file system.
Right.
Hmm? But in the case of your Linux operating system, sorry, but in the case of your HDFS, what happens is that even though the default block size is 128 MB, and if you are able to utilize only this particular 49 B or whatever it is, what happens is that the unused space what you are having here will be utilized by some other processes or some other programs. That's why you can have the option of utilizing your space efficiently in the case of this virtual file system of HDFS. Clear this one?
Yes, yes, yes. So I think I remember this in your first class itself. You told
Yeah,
that
I was telling you the
last
same thing.
block, if it is less than the block size, the file, the last block that is getting allocated, it will if the depending upon the file size, it will not necessarily take 64 MB or 128 MB. It will take lesser than that actually.
Only whatever is required, only that one only will be able to take,
Right.
and we'll be able to look on to that one here. Okay.
But
Now,
what about in Windows, there is a defragmentation concept is also in file storing, where is the empty file is now 1096 MB, then defragmented process can be used to any other place, other storage, other things in storage,
that
Windows
is
as
the
well.
post maintenance activity that will be working on Camrun, right? That is a post
Yeah,
maintenance activity. But for now, whenever the file is being allocated, this is the thing mandate behavior that we can have in the case of the Linux or in the case of this Windows operating system. So what I'm trying to say is that HDFS behaves differently because it doesn't try to leave that space as it is. It will be allocated to the some other process also as well. Okay, that's how it is going to
okay,
happen.
okay.
The reason why I'm showing you all these things is I hope you'll be able to map this particular content with respect to the HDFS architecture what I have told you in the previous set of classes. Okay, and another thing is that I have told you one more concept called as WRM. What is that WRM?
Write once and read many
Right
times.
once, read many
Write once
times,
and read many times.
multiple times.
Okay. So even when you see here, all these particular groups, except that particular user who has created these particular files, he only have its read-write mechanism, but the group or that other groups will only have this particular read permissions for the purpose of accessing these particular files, but they don't have any write permissions as well as the execute permissions here. Okay, this is one thing that you need to understand. See, this is what is your contents here. So you're able to see these particular directories. Okay, suppose if you want to know what is this particular file.txt, you can go here, you can see here, hi, how are you, and how are your Hadoop classes going on? How are your Hadoop classes going on, Sarvanan? Are they going good, bad, ugly, or whatever it is? So this is how this is going to see the things. But the problem with respect to this browser-based access is you will only be able to view the content, but you will not be able to make any changes to that particular content, right?
Correct. So even in the new versions of Hadoop, update is not supported, right, Ravi?
No,
New.
no.
Oh, okay.
Even in the new versions of Hadoop also what happens is you can have the option of maintaining the versions.
Okay.
First version, second version, third version you can maintain. Otherwise what you can do is that you can delete that particular content and then you can override that particular content. That is possible. But making the changes to that particular content is never permitted in the case of this Hadoop distributed file system. Okay.
So the only use case for Hadoop is then analytics. As compared
That is the purpose why this particular big data has come into the market.
Okay. No, why I was asking that question is like NoSQL and all that, they can write many times and read many times, like Cassandra.
Yeah.
So
Then next is
analytics,
also the NoSQL database, which is a columnar database where you'll be using the SQL on that one for the purpose of writing and all. So that place also, it is a warm method only. Write once, read multiple times over there. Cassandra, MongoDB, these are all the things which are green plum. These are all the things which has come on that particular concept only here.
sure, okay.
Okay. No. This is clear, right? So what should we do now is that the main purpose of trying to work on this HDFS file system and this Linux file system is you need to really understand and then do the gap analysis between how you can work on this Linux file system as well as this particular Hadoop existing file system. So this is what is your browser-based accessing of this Hadoop file system. Of course, we have seen only two things. What are the two things here? We have seen the data node as well as we have seen this particular name node only, right? Now, for the purpose of interacting with respect to the terminal, okay, what we need to do here, we need to go enter into this particular terminal. So now tell me, Dvijaya, now tell me in what mode we are in. We are in the Linux operating system, we are in the Hadoop operating system. Sorry, Hadoop file system. Are we in Linux or are we in HDFS? When you open the terminal on Linux operating system.
Linux operating system.
We are in the Linux operating system. We're in the Linux operating system. Okay. Now, if I say something else pwd, this is nothing but a present working directory, which is /home/edureka. /home/edureka is your Linux home directory. Is your Linux home directory. Okay. Now, for the purpose of interacting with Hadoop file system, the first thing what I need to do is that I have two options. Maybe you have read, I can have the option of using something called as Hadoop. Okay, you can. The first thing what you can do is that you can have the option of checking this particular version. The Hadoop version what you are having here is 2.2. Okay, but there are so many versions that are coming onto Hadoop and all, but there are only two stable versions that are available. You can have the option of using. You can have the option of using what we can say here. 2.2 version, which is a stable version, as well as 2.6 is also another stable version that you are having here. Okay, so let me mask the screen for 1 minute or so, and then I'll tell you. I'll try to connect to a putty.exe, and then I'll show you what version of Linux what you are having over there. Okay, so Sarvan and other guys, please bear with me for a minute or two. Okay. So I'm showing you this entire screen. Share the screen here, and then go to this putty.exe, and here I'll give this particular paste, and then click on this open. When I start opening, it will be asking me the user ID and password. This is putty.exe. It is a lightweight application where you can connect to that particular virtual machine which is on the cloud or on a particular data center, and then you can start accessing. Network connection timeout. Maybe multiple people might be using that one, but it is time. But I'll show you that one here. Don't worry on that piece. Okay, I'll come here. Now, for the purpose of working on this particular Hadoop file system, the one option what you're having here is you can use something called as Hadoop FS, sorry, Hadoop space FS, okay, and I can specify something called as minus ls, hyphen ls. To differentiate the commands what you are giving at the shell, and then in order to make sure that your interpreter is correctly understanding this particular commands, what you need to do is that you need to give it as Hadoop FS, okay, and then you need to specify minus ls. When you use something called as minus ls, what I need to do, I need to list out all the contents what are present in my directory over there. So how can I know this one? The moment once I click on this particular enter, I'll be able to see here. Are you not able to see here? One is your cache, the second is file.txt, first hdfs.txt, first hdfs.fl, seco, and second and second. These are all the things what I'm having here. How do you know that one? Whether they belong to this one or not? The moment once you go to this particular one minute. The moment once you open this web browser, okay, what it did? In the case of this slash user slash edureka, don't you think that these are all the things that you are having here? What are all the things what you are seeing here? Is it not the same that are being displayed here also as well, server run? Clear what we are doing? To list the files, we need to use this particular command.
Okay.
But if you want to list the contents of the root directory, how do you know that this is belonging to this one? Why? Because this is nothing but your slash user slash edureka is nothing but your home directory of your virtual file system. That's why you're able to display. Okay. Suppose if I want to display the contents of my root directory, what is the root here? This root. When I try to say something called as this root, what you're going to get here? You'll be able to get, see here. You'll be able to get slash temp, slash user, and then slash USR you are getting here. What are these things here? These are nothing but the directories. Why? Because every entry is starting with D. That's why these are the three directories that are present within your root directory of your HDFS. Okay. Now, suppose if you want to get only this root directory like this, ls root directory, what happens? You'll be able to get these things. So don't you see that this root is different from that particular root? Sarvan?
Yes.
Murli and Kamran, I hope you guys are following.
Yeah, right, yeah.
Vijay? Okay. Okay. Now, in Linux operating system, can you change directories or not?
Yes. I mean, change between directories, right?
Yeah, so you can change between directories.
Right.
But in the case of the Hadoop operating system, in the case of the, it's not an operating system, it is in the case of the Hadoop file system, you cannot change the directories. You cannot change the directories. That means that CD command is not possible in the case of this HDFS basically. Okay, you cannot do that one. But you can have the option of creating the directories. You can have the option of creating the directories. Okay, now suppose
why it is not possible in Hadoop?
it is a virtual file system.
Why?
Right?
Okay, that's the reason.
It is a virtual file
But
system.
we can. Okay.
In virtuality, how do you think that you are changing from one directory to another directory until and unless you feel the things?
Oh yeah, I agree.
So creation has to be done through Linux, or in Hadoop file system you can create.
Now in Hadoop file system, you can have the option of creating the directories. I'll show you. So what I do is that I use something called as HDFS. So what I can do is that I can specify something called as HDFS fs. Any command that you are giving here should always start with -mkdir, and here I'll create something called as Ravi. Okay. Now tell me in which directory this Ravi is going to be, in which place this Ravi is going to be created. In which directory this Hadoop is created? Sorry, in which directory this Ravi is created?
In Hadoop directory, I think.
No? In the home directory of HDFS that is created. In the home directory of HDFS that is created. So how do you know? Assuming that I have given like this. See, it is HDFS fs minus mkdir. Sorry,
Do you
it is
mean
not. It is Hadoop fs, right? Sorry.
Yeah.
Hadoop fs minus mkdir. What is that one? Okay, is it clear now? That is created. How can you check whether that has been created or not? You can specify something like HDFS. Something like Hadoop fs. Okay, /ls. You can also give this particular path, that is /user /edureka. /user /edureka. Okay, so HDFS fs minus ls /user /edureka. When I give this one, what is going to happen is I'll be able to see that particular Ravi directory under that one here. How do you know that whether Ravi directory is existing or not? Don't you think that this Ravi directory is existing here? Sarvan, you are seeing, right? Ravi directory is there.
Yeah.
What is your Ravi directory?
Yes, there.
That is created here. 980. That is the place where Ravi directory is getting created. Suppose if you want to use HDFS, what you need to do is that you need to specify something as HDFS DFS. Okay, minus ls, that is -ls /user /edureka. Tomorrow, if anybody can tell me, what is the major difference of using HDFS and Hadoop commands, that would be really great. If I give this one also, I should be able to get that one here. You're right. HDFS DFS you need to use, or else you need to use Hadoop FS you need to use basically. Okay. Any questions so far, or you are clear, guys?
What is the use of just creating directory here?
The use of just creating the directories is the moment once you are going to use this particular MapReduce commands, MapReduce programs. Okay, this particular MapReduce is going to write some files into the directories that you are specifying. That is the reason we need to create this particular directories upfront. Okay.
Okay.
Now you'll be able to understand once we go on to this particular map reduce. So this is done. Now, if I want to, suppose if I'm using something like HDFS FS minus LS, what I do is that I'll specify something as Ravi slash data slash athletics. Tell me what happens. Will it be created or it won't be created?
It won't be created.
Why?
It won't be created.
May know the reason why it won't be created. In the case of
Last time you use a switch dash P something like minus
yeah,
P.
that is what is called as the progressive creation.
Progressively,
That
progressively.
was called as a progressively creation. But in but in the case of HDFS, there is no need for you to specify that progressive creation. Minus P is not required here. The reason why minus P is not required here is if Ravi is existing, it will go ahead into that Ravi and then start creating this particular data. And if data is existing, it will go ahead and then it will create this athletics as a subdirectory. Okay, but if Ravi is not there, it will create Ravi, and within Ravi, it will create data, and within data, it can have the option of creating this particular athletics. So if I give like this, see whether it is going to create or not.
Make directory or ls? You gave ls. Right?
Sorry. It is created. How do you know that whether it has been created or not? One way is that you can check it here, or else you can also go here. Slash Edreka. You refresh this one. Go to refresh here. So this is the Ravi that is created now. When you click on this Ravi, you will be able to. Oh my God.
Empty directory, go parent.
This is what is your Ravi. Maybe I need to refresh. Hadoop name node. Go to this file system. You go to this user. Go to this Edreka. You select Ravi. What's going on, man? Suppose if I give something like Hadoop, okay, fs minus ls slash Ravi, sorry, slash user slash Edreka slash Ravi. What I should be able to see? I should be able to see the data. Is it not created or it is created?
Directory is not created. I think you forgot that Ravi slash Ravi, right? Slash.
Yeah, sorry. Even if I don't give also, it should be able to create that. Even if I don't, doesn't matter.
I mean slash use. Okay. So Ravi is your.
It should be given only as slash Ravi only.
No, I mean the full path basically, or tilde slash.
No, why? Because it assumes that that is going to be the root directory only over there. Okay, suppose if you try to give only data till this particular point of time, see here. Ravi slash data. It is creating. Now, when you use this one as like this, progressively also should work. I really don't understand why this is not working here. Maybe this is the Hadoop 2.2 version that may not be working. If you have something like 2.6, you may be able to try here. Now, if you go to this Hadoop system and then go back to the parent directory, see this particular Ravi, then you'll be able to see the data, then you'll be able to see this analytics. Clear? Murli and Kamran and Sarwan.
Right. So here you are able to change the directory. I mean, you are able to go to the directory
I'm only trying to list the contents of the directories, and I'm able to create the directories, but you cannot change from one directory to another directory in the virtualization world, right? You cannot be able to do that one. That is something that you need to understand. Okay. And yesterday I was telling you I'm going up here in 2 minutes, but now here let me tell you one thing. This is your Linux and this is your HDFS. Initially, when you are creating a file, when the client is going to create a file, where is that particular file expected to come? It can. Do you think that it can directly come into HDFS? This is your client. Okay. This is your client. Do you think that client can interact with Linux, or client will interact with this HDFS? With what client will be able to interact? Sarwan?
The client will interact with the Linux actually,
Yeah.
and a layer of
So
abstraction over Linux.
that means that he need to bring the file into this one first. You need to bring the file here. You need to bring that particular file here. The moment once the file is brought here, then only he can have the option of putting this particular file into HDFS. So that's why you need to have the interaction of how to transfer the files from local file system to the HDFS file system, and get the files back from the HDFS to the local file system. And yesterday I was telling you two things, right? I have told you something like CP, which is nothing but the copy paste, and then MB, which is nothing but the cut paste. How those two things are going to work over there, and then how can you transfer the files between the directories? These are all the things that we'll be seeing in tomorrow's class before we close this particular Hadoop distributed file system. Okay, are you guys clear with what is happening since last couple of days?
Yeah. So Ravi, if I remember one of your classes, you said that each block of the file in HDFS is a file in the data node. So when a file is ingested by HDFS, is written to HDFS, and then it goes to the data nodes in the workflow, like you mentioned yesterday.
Yeah,
Each
exactly.
block
Yeah.
is written as a file. Each block is written as a file in data node.
Yeah, each block is written as a file. Yes, each block is written as a file, and we don't call that one as a file, but we will be calling that one as a split. We'll be calling that one as an input split. What we call that is the correct technical language that we need to use. We'll be seeing that one, Sarvan. Once we come on to this particular map reduce, we'll be able to understand that one.
Okay, sure.
Okay.
And Ravi, one request actually, can you please go and double check it, because all the material I am seeing, what it is telling is that HDFS writes are block by block, meaning it is sequential. I understand your logic. You are telling what logically why can't it write to multiple data nodes. I also feel the same way. But all the material I'm seeing, it is saying that the writes are block by block, whereas the replication it is happening in parallel. So that's what I'm seeing. Can you check at your end?
I'll double check that one. That should not be a problem. But one thing is that I have attended the webinars and seminars of those who are treated as the gurus, basically. Okay. I attended those seminars, and then when they were explaining back in 2014 or 15, 14 I think. When I was attending those particular webinars, I used to understand two things over there. I used to understand two things. What we can say is how can we how can this file writing and reading that happens in this particular HDFS, at that point of time they have told me logically, I
Yeah.
raised that question also as well. That is
Oh,
something that is stuck in my mind.
okay,
Okay,
okay, okay.
so
Okay.
logically also this is correct only, right? Why? Because
Logically, I agree with you. Logically, I agree with the explanation. The same thing was in my mind also. Logically, it is there. But if you look at the Edureka question and answers, it is written that it is happening sequentially. Edureka Hadoop interview questions. I'm not relying only on that. I have so much other material actually. But in the Edureka
see, oh,
question and answer,
see, yeah,
good.
let me tell you.
Yeah.
Edureka, IntelliPat, and the XYG things, these are the people who are like you and me, who have cross-skill, upgraded, worked on 2 or 3 projects, and then they are uh, they are doing this evangelism.
Okay.
Okay. Now there are some people who are treated as the gurus or pandits of this uh, data science and big data, right?
Okay.
Anyway, I'll check that one and then I'll confirm, but I don't want to get into the argument mode. But yes, we need to check and then we need to double check that one also as well.
Sure. Sure. Thank you.
I'll do that,
Thank
no problem. Okay, so that's all from my side, and we'll meet tomorrow. Tomorrow looks like Kamran is having some upgrade that is going on. He's telling. He told that he'll be able to join by 10:30. Uh, Maybe if you are going to have the session by 10:30, Divya, it will be 9:30 for you. If that is the case, what we need to do is that we'll need to have only the 45 hours, 45 minutes discussion that need to happen tomorrow. Okay, and then we'll be continuing this one starting from Monday. The map reduce and other things. Okay.
Monday it's going to be that daylight time savings, right? So is it the same time that you're going to follow?
We are all in US, right?
Yeah, or you want to like?
I think that there is no one who is joining from India. In case if somebody is joining from India, that might really matter. But for now, what we do is that we'll keep this particular timings for a couple of days. The moment once we feel that we are getting stressed out, then obviously we'll move it to one more hour ahead before we'll move. Murli, is it okay?
Okay, okay.
Let us keep the timings 22, same timings 22 for 4 or 5 days. For the next week, let us keep the hours 22 and then we can decide. Okay?
Yeah, it's fine. Yeah, for me.
Okay. So please wait for
Last
2 or 3 days. Yeah, tell
So
me.
we all are in the North American zone currently, time zone.
But only one
North
lady is
America zone.
Divya. Divya is in CST. CST time zone. Anyway, that may not be a big problem for her. She might be able to attend. But anyway, we'll go ahead with 10 for the 10 o'clock for the next couple of days. Then we'll decide whether we need to switch or not, depending on the way the things are going on. We'll take a call. Okay.
Thank you.
Thanks, guys. Yeah, no problem. Yeah, thank you and have a good night.
Good night.